Okay, radical equations are, these are pretty difficult. But it's easy to make a mistake. I shouldn't say they're difficult. It's easy to make a mistake with them. Well, the first thing you do is with any radical equation is you isolate the radical. Well, in this case, we've got two radicals. We've got 3x minus 5 under the radical and x plus 2 under the radical. And so what we're going to want to do is go ahead and square both sides to start with, to try and eliminate the radical. That's the inverse of it. So you square both sides of the equation. And so what that makes us have to do is, since this whole thing is a binomial, we're going to have to write that out twice. So the square root of 3x minus 5 minus the square root of x plus 5, and then, or x plus 2, I don't know where the 5 came from. And then the square root again of 3x minus 5 minus the square root of x plus 2, and then equals 1. So what we have next is to distribute through on everything. So, you know, 3x minus 5 times 3x minus 5, and they're both radical, would be 3x minus 5 squared, which the radicals would cross out then. And maybe I should write that so that we can follow along. So that'd be 6, that'd be squared. And then you'd multiply this one, so that'd be minus square root, and I'm just going to write it all as 1 square root, 3x minus 5 times x plus 2. Okay, then we'll do it again with this one. So minus square root of 3x minus 5 times x plus 2, and that was this one. And then the last one, minus, or plus, excuse me, square root of x plus 2 squared, and that all equals 1, because 1 squared is 1. Now if we go ahead and simplify this expression, we'll kind of bring this down. Square and square root are inverses, and so we'd have 3x minus 5. There's 2 of the very same thing, so minus 2, and then square root of 3x minus 5 x plus 2. And then plus, again, square and square root cross out, and so you're left with x plus 2, not that you need the parenthesis, and that equals 1. Alright, so we still have a radical here. That's kind of a pain in the butt, because that means we're going to have to square it again. But before I do, you want to get that radical by itself. So combine what you can, move everything else to the right. And so what you notice is we've got 3x and x. So that would be 4x and negative 5 and positive 2. And that would be minus 3. And you want to really watch out to make sure you don't make a mistake, because that's one mistake kills you in this thing. And that equals 1. And then I'm going to move everything to the right, and so I'm going to subtract 4x and subtract 3, so minus 3 and minus 4x. And so we've got negative 2 square root of 3x minus 5 times x plus 2 equals, let's make sure that's right. Oh, it'd be plus 3. I was going to say, I didn't see, there was that error I was talking about. I was yammering. To move the 3 over, it had to have been plus 3 to both sides. So that would be 4 minus 4x. Okay. What's nice, we could go one more step here and divide everything by negative 2 on both sides of the equation. That would eliminate that part of it. And so we've got parenthesis 3x minus 5, x plus 2 equals and I'm going to rearrange it. I'm going to divide and use the commutative property, which would give me 2x minus 2. 2x minus 2, yes, because 4 divided by 2 is negative 2, and negative 4x divided by negative 2 is positive 2x, like I have there. Okay, so now that I have the radical isolated, we can go ahead and square both sides again. This time, the square and the square root cross each other out. So on the left side, you're left with 3x minus 5 and x plus 2. On the right side, you got 2x minus 2 squared. So you'd have to write that out twice. Okay, and so now we're just ready to distribute again. So that'd be 3x squared plus 6x minus 5x minus 10 equals 4x squared minus 4x minus 4x plus 4. Alright, I'm going to move everything to the right because I want my x squareds to be positive and combine as I go. So minus 3x squared over here. I'm going to add 10 over here. I'm going to, this is going to become, this simplifies to 1x. So I'm going to subtract 1x. Okay, and so we're left with 4x squared. So 0 equals, kind of shifting everything over, 4 minus 3x squared is just x squared. Negative 4x here in the middle, negative 4x, and negative 1x is negative 9x. And positive 14. And so this factors to x minus 7 and x minus 2. And so using the zero product theorem, we know x minus 7 has to be 0 or x minus 2 has to be 0. And so x would equal 7 or x would equal 2. Now I box those answers in, but there's a possibility that one of those or both of those answers won't work. And so you have to go clear back to the original, which was square root of 3x minus 5 minus x plus 2. And so we're going to plug those in and make sure they work to the original. So let me recopy it here. So 3x minus 5 equals the square root of, or no, sorry, that's a minus. So this is my original equation, x plus 2, and that equals 1. So I'm going to plug in a 7 to start with. And so you'd have the square root of 21 minus 5 minus the square root of 9. And so 21 minus 5 is the square root of 16, which is 4, minus 3, and that's 1. So x equals 7 is going to be just fine. Now for 2, we'd have the square root of 6 minus 5 minus the square root of 0. And so that would be the square root of 1 minus 0. So 1 minus 0 is 1. So that one also works. So excellent. We've got our two answers. Nothing was eliminated. If you have questions on this, make sure you ask. Go ahead and comment. Send me some more information about what problems you might be having. Best of luck, and see you next time.